Hey everyone, I'm Sam Alsup, and today I'm going to be explaining binary search and how to use it to solve programming problems. So basically, binary search is a searching algorithm where given an input of a sorted array and a target value, we can output the index of the target value or -1 if the target value can't be found in the array, all in a time complexity of O of log n. The pseudocode is pretty straightforward. We check the middle value of the array, and if it's the target value, we return that index because we found it. And if that middle value is less than the target value, we set the start and end indices to squeeze the values to the right of the middle. So basically, instead of giving the start and end indices with the start as 0 and the end as the length of the array, we would now switch the start to be the middle so that we're only looking at the right side. And if the middle value is greater than the target value, we do the opposite. We set the start and end indices to squeeze the values to the left of the middle, meaning we change the end from the length of the array to be the midpoint and keep the start at 0. So we're just looking at the left. And essentially, all that's doing is dividing the possible indices by 2 every time we check the middle value. So that's why binary search gives us a time complexity of O of log n. So now we'll do a short example to kind of illustrate how it works. So given this input array of 1, 3, 4, 9, 11, and let's say the target value is 11, this is kind of how it would function. So let me just write these out. So we have 1, 3, 4, 9, 11. And their indices are 0, 1, 2, 3, and 4. So basically, we would calculate the midpoint by just doing start plus n divided by 2. And so basically, that would just be 0 plus 4 divided by 2, which would be 2. So this would be our midpoint, and we'd check. We'd say that 4 is less than our target value of 11. So now we're going to set the start to be the next indices. So now start would be 3. We're just going to look at these. So then we'd have start plus end divided by 2, which would be 3 plus 4 divided by 2. So that would give us 7 divided by 2, which is going to truncate to 3. So this will be our midpoint. And we see that 9 is less than 11 as well. And then we're going to change accordingly. So now we'll change it to just 4 is now our start and our end. So then we would calculate our middle. It'd be 4 plus 4 divided by 2, which would be 8 divided by 2, which is 4. And then we check. And 11 is indeed equal to 11, which was our target value. So then we return the index. We can just return start, or not start. We would just return the current index that we're at of the midpoint, which is 4. So then it would return 4. And that's basically just a very simple example of how binary search works. And then, so now we're going to try to use that to solve a problem. So this problem is called search in rotated sorted array. So essentially, we're given an integer array called nums that's sorted in ascending order and a target. So basically just what we need for binary search. But then we have to suppose that that array is rotated at some pivot. So as you can see, 0, 1, 2, 4, 5, 6, 7 became 4, 5, 6, 7, 0, 1, 2. So it's just randomly kind of rotated around so that the start value is now just somewhere in the middle. So it's pretty clear that all we need to do to be able to utilize binary search is just to find the pivot index so that we know where to start looking and then where to end looking, and then we'll be able to utilize binary search. So I usually implement binary search iteratively, as you can see below. I have the function written out. There's not really an advantage of recursive versus iterative. So I just use a while statement and I calculate the middle. I check to see if middle is equal to target, and then I return the middle if that's true. Otherwise, I change the start and end equivalently so that the while will just keep going. And if start ever gets, incremented too much or end gets decremented too much, then the start will be greater than the end, and that'll return -1 if for some reason the target's not in there. Otherwise, it'll work. And if you wanted to do it recursively, it'd be pretty simple. You just instead you still do the if statement, but then on the else if, you would just return binary search of the same array nums, and then you would just change start to be middle +1, and then you would do end and target. And if you were doing it in the else, then all you would do is return binary search of nums start, and then instead of end, you'd put middle -1, and then you'd put target. So I implemented that real quick. And then I implemented a function called find pivot index. And this is also, you can kind of use binary search in doing this because it's kind of like using binary search, but instead of the target value, we're just looking for the least, like the smallest value. So all we do is we only supply a start and an end, and then we just say while start is less than end. We basically just keep converging until we hit the smallest value. So we just check the middle one, and if the middle is less than the one on the end, then we make the end equal to the middle. So we just look to the left, and then otherwise we look to the right, and we just keep going in half until we converge on to start and end as the same. So basically it's just until we find the least value and we return it. So that's how we find the pivot index. And then in our main function in search, when we're just given the array and the target, we just find the size because we're going to need that. And then we find the pivot. And then all we're doing is we're going to check the target against the final value in the array. And basically we know that if the target is greater than the thing at the end of the array, then we know that it needs to be to the left of the pivot. And if the target's less than the end value, then we know it needs to be on the right. And then based on that, we'll binary search based off that essentially. So if the target's greater than the end value, meaning that it would have to be to the left of the pivot, then we're going to binary search given like 0 as the start and then the pivot, because we know it's got to be to the left of the pivot or the pivot. And then we'll return that value. Or if the target is less than the number at the end of the array, then we're going to binary search from the pivot to the end because we know that it's somewhere in that range. And then we'll return that. So that's essentially how we can use binary search in programming problems. And there's a lot more like this, where if you think about a way to utilize binary search, you can kind of just split up the problem into 2 ways. First, you got to get the problem into a place where you can use binary search. So overall, it's very useful for a lot of problems. Thank you guys for listening to this tutorial.